During DNA replication in prokaryotes, the process of elongation is crucial for ensuring that genetic information is accurately copied. It all begins when DNA double helix unwinds, creating two single strands. Hey there, before we dive into today's content, I want to take a quick moment to remind you about something super important. If you are not subscribed to our channel yet, now it is the perfect time to hit the subscribe button. Trust me, you don't want to miss out what we have in store for you. Now it's time to go through our topic, DNA replication elongation in prokaryotes. Before the start of elongation, primase synthesizes short 10 base pair long RNA primer. DNA polymerase cannot able to add nucleotide without an RNA primer. It provides a start site as a free 3' group of polymerase to work. The elongation is a step in which DNA synthesis is initiated. Once the double-stranded DNA becomes single-stranded, the polymerase settles on the junction of DNA-RNA primer. The first DNA polymerase is isolated by Arthur Kornberg in 1959, and he was the first person who synthesized the first DNA molecule in vitro. Three different types of DNA polymerase helps in the prokaryotic DNA replication. They are DNA polymerase 1, DNA polymerase 2 and DNA polymerase 3. DNA polymerase 1 removes the RNA primer by exonuclease activity and proofreads the DNA. But the DNA polymerase 2 mainly in the DNA repair pathway. Then what do the DNA polymerase 3? DNA polymerase 3 adds nucleotide from 5' to 3' direction. Once the chromosome complex is created, chromosome complex means the complex of primer helicase complex. Polymerase recognizes it and starts the polymerization process at the leading strand. Then we have to look at the activity of DNA polymerase. The DNA polymerase synthesized both leading strand as well as lagging strand at once. It is possible with the help of two subunits of DNA polymerase 3. Both subunits have different properties, as one is specific for leading strand, the other is the lagging strand. The process of replication progressed in 3' to 5' direction, while the polymerase 3 adds the nucleotides from 5' to 3' direction. The sliding clamp holds DNA properly and prevents them from floating off. Next, look at how the leading strand synthesizes. A 3' OH end of the single-stranded DNA is called leading strand. The primer is first bound to this end after the recognition of primer binding site. As the helicase moves, polymerase 3 adds the nucleotide from 5' to 3' direction on drawing leading strand. During the process of replication, 1,000 nucleotides are added per second. The leading strand DNA synthesis is very straightforward. It starts chromosomes and continuously adds the nucleotides until the termination sequences. The termination sequences are unique conserved sequences which are recognized by polymerase as the end of replication. Then, how the lagging strand DNA synthesizes? The lagging strand DNA has 5' open end. Hence, the polymerase cannot synthesize new DNA from this direction. The lagging strand DNA synthesis is a little different from the leading strand. Here, primase synthesize multiple primers. Lagging strand synthesized in a short DNA fragments called as Okazaki fragments. Subsequently, each new primer is added after 1,000 nucleotides. After the synthesis of Okazaki fragments, the sliding clamp is removed. Once again, new primer is synthesized by primase and binds to DNA. Further loaded by sliding clamp loader and synthesis of new Okazaki fragment begins. Thank you for being here and thanks for watching this video. Don't forget to subscribe to our channel so you can join our awesome community.